Good morning or good afternoon, everyone. Welcome to the From Grapes to Wines Cool Climate webinars. My name is Neslihan Ivit. I am the winemaking and innovation specialist in Perennia, and today our co-host is Francisco Diez, viticulture specialist. And we are both very excited and honored to host Dr. Maret de Toit, who will be talking about cool climate malolactic fermentation and answer the question, what does it mean in the year 2022? Before we begin, I would like to give some Zoom housekeeping items. You will have your audio and video turned off during the webinar. To ask questions, please use the Q&A feature at the bottom of your screen. And we will be monitoring the chat and Q&A throughout the session. And at the end of the presentation, Francisco will be addressing your questions to our speaker. An introduction to Perennia. Perennia is a provincial agency with a vision of that Nova Scotia is a recognized world leader in producing innovative, environmentally responsible, safe food of impeccable quality. Perennia's mission is supporting growth, transformation, and economic development in Nova Scotia's agriculture, seafood, and food and beverage sectors. Our service areas are agriculture, quality and food safety, product development. We have lab services, as well as fisheries. And our wine services extend from vine to wine. We offer site assessments. We have viticulture services. We have a plant health lab. We offer winemaking services and mobile bottling and filtration. And we have efforts for industrial development, such as today's presentation. And today's webinar will look deeply into malolactic fermentation, MLF. MLF is a traditional winemaking technique which has relevance until today, continued its relevance in modern enology. And if we want to define MLF in a very simple way, in one sentence, we can say that it is the bioconversion of malic acid into lactic acid, helped of the lactic acid bacteria. And the main aims why we use MLF in winemaking is the natural deacidification, microbial stability, and enhanced aroma and flavor complexity that it provides. With all these aims, MLF is used in most red wines, but also in some white wines and sparkling based wines as well. And when we come to applying the MLF, we can see it as a strategy to be able to achieve the wine style that we have in our minds. For that reason, we have to consider some of the grape juice and wine parameters. Those will be both important for a complete MLF, but they will be also important for the sensory characteristic of the final wine. To give some examples of those parameters for MLF, they will be pH, ethanol, sulfur dioxide, and temperature, among many others. And of course, all these parameters will lead us for some decisions to make for malolactic fermentation. That will be, for example, the first one, of course, will be if we will inoculate with a starter or if we will make a spontaneous one. And if we will inoculate, which lactic acid bacteria that we will use. And also how it will be compatible with the yeast that we use, because they will have to interact. And also the important is the inoculation time. We can make it during the alcoholic fermentation or afterwards as well. All this decision will lead us in the aimed wine style that we envisioned. And on top of that, we have another layer of challenge coming from the cool climate wine growing regions, such as high acidity and low pH. Considering all this, it's important for us to keep updated our knowledge in this topic. That's why we have invited Dr. Maret de Toit to present us today. Dr. Maret de Toit has a PhD in microbiology from Stellenbosch University. She's the professor in enology, specializing in wine microbiology. She's the head of Department of Viticulture and Enology. And during her job, she graduated 39 masters and 9 doctoral students, published 73 peer-reviewed articles, presented over 200 papers at international and national conferences. She works also as associate editor for the scientific journals South African Journal of Enology and Viticulture and Frontiers in Microbiology. Her research topic focuses on the use of novel lactic acid bacteria for MLF and also interaction with wine yeast and influence on the wine aroma. On top of that, she has been involved in the commercialization of several MLF starter cultures for wine industry. With all these, please join me welcoming Dr. Maret to Toit. Thank you very much, Maret. I'm leaving the floor to you.
Yeah, good afternoon, everybody, from a very hot Stellenbosch. It's around 35 degrees today, so I think it's a bit different than what you are having there in Nova Scotia. So I would like to thank Perennia for the opportunity to discuss malolactic fermentation with you, and also for Nestle and Francesco that guided me in the process and who will also be my right hand in the online space. You always need a right and a left hand, somebody who can monitor the chat and look at the questions. So they've basically asked me to talk about cool climate MLF, which I think has the same type of challenges than warm climate MLF. They're just a bit different. So, and in 2022, what do we know? What are the challenges and so forth? So let's see how well the online space works. So I would like for you, maybe in the chat room, if somebody is willing to obviously unmute themselves, you're also welcome to talk, is to first say what has changed according to you in the last decade with regard to MLF. So in your perspective, being cool climate, what are the things that you think are important to take into consideration for successful MLF? So what are the practices that is preferred in your area? How do you handle MLF? How do you think about it? And then do you inoculate? Do you rely on spontaneous? And if you inoculate, what are the main bacteria that you will look at? And being cool climate, what are the factors that has the most negative impact on the success of MLF? So we will give a minute and then Francesco will either tell me, yes, there's been reaction, or no, we progress. So if you are willing in the chat room, I mean, it can be very critical. You can just highlight the things that you feel is the most important to take into consideration in this discussion. And this will also guide me more or less, where do I focus my attention on? I assume chat or Q&A can be used for making comments.
The chat is open if somebody wants to write an answer to Toit questions.
Okay, it seems like everybody is still in morning mode.
We are excited to hear you, Maret.
Okay, that's good. So if you think about things, obviously you can write them. This is an open discussion, and in the end there will be a Q&A session. So if there's anything during the presentation that you would like to ask, you do not have to wait until the end. You can then add it to the Q&A or the chat room. So So obviously, what do we know about MLF in 2022? So it's fair to say that until a decade ago, most people did malolactic fermentation to ensure they reduce their malic acid concentration, because we all know malic acid has an impact on the sensory profile. It contributes to low pH and acidity of the wine, and in certain areas it was beneficial to degrade malic to lactic acid, and the main driver that was used was Unococcus uni. It's the bacteria that was first discovered, and until today it is still the bacteria that's best adapted to the most widest parameters that we experience in the winemaking process. So the main purpose of MLF is definitely still to ensure malic is converted to lactic. Maybe the difference between cool and warm climate regions is obviously much more pronounced due to the difference in levels. But today, I think the exciting part of MLF, about 8-9 years ago, we started looking at Lactobacillus plantarum, or today we call them Lactibacillus plantarum. But luckily, from an abbreviation point of view, it still stays the same as L. plantarum, where we realized that, as Nestle said, you have two options to inoculate, co-inoculation versus sequential. And obviously, the grape matrix is very different to a wine matrix, which opens up the floor for new bacteria to enter the winemaking process. And obviously, the genetics behind the two, the genomes are different. And that means the impact on the flavor and aroma profile is also very different between different strains. So obviously, we have a lot of opportunities. You as winemakers have to make crucial decisions. You have quite a lot of things in your toolkit now that you can use to tailor or make your wine style to what you would like it to be, by also using different bacteria or different strains in the wine. So this is the, I think, major shift that happened in the last decade. Our primary role for MLF is still malic to lactic, but now we have started to use the added value of the different strains to also tailor the sensory and the aroma profile of wines. And those we will discuss as we go along. So as Nestle has indicated in her introduction, so the major role, as I said, is still deacidification of wine, using bacteria to degrade malic to lactic acid, and obviously in cool climate to make the wines more palatable, reduce the acidity where the modern consumer can find the perfect wine and the perfect acidity. That is still the major role of MLF. Then obviously removing malic acid, which from a carbon source is the major carbon that most of the wine LABs can use. It provides microbial stability. So in warmer climates where the pH is higher, you have a much higher risk of microbial spoilage by LAB. And therefore, this provides with sulfur some security in the wine. And then, as I say, today, we also use MLF to drive the aroma and flavor profile of the wine. So if we have to summarize the impact of MLF, if you have a non-MLF and an MLF wine, they will be described as being more complex because you've got added aromas. They are better structured. The palate will change. You can provide more butteriness or not, depending on the style you're driving. There's a reduction in the vegetative aroma, so some of the bacteria will produce less of your higher alcohols and aldehydes, which contributes to the green characters, and they will produce esters that will enhance the fruitiness. So this will be over and above what alcoholic fermentation and the yeast will provide. But as with anything in wine or in grape, we have to consider certain factors that bacteria are more resistant or sensitive to. And there's a whole list, but for today's discussion and webinar, we will focus on pH, which are interlinked to ethanol concentration. So then malic acid concentration in cool climate wines is obviously crucial because it's quite high, and I will indicate why it's important. As a winemaker these days, you will decide on the perfect yeast, perfect nutrient strategy, but many winemakers still do not think about the yeast and the impact the yeast will have on the bacteria. So we will look at the interaction. Nutrients are important, and then what are the inoculation scenarios that you can use. So we will focus on those because I think those are the most prominent related to cool climate areas. So as I say, commercially today, the two species that are available is Unococcus uni, and as I said, it is still the bacteria that is the best adapted, so that it has the widest pH range it will function on in a wine matrix. So obviously the lower end of the pH spectrum is more cool climate, and there the Lactobacillus plantarum struggles a bit. Unococcus uni can also grow during winemaking, so it can resist up to 16% ethanol. Obviously not all strains. There are strains on the market that have specifically been selected for this. They can work at low temperatures. Obviously all of this, if you have a low pH, a higher ethanol and low temperatures, plus some sulfur, it will extend the period of MLF. So obviously, the better your parameters are aligned with the bacteria you choose, the shorter your MLF time will be. And obviously, Unococcus produces some acetic acid if they use a bit of sugar to enhance their viability and to produce enough ATP to grow in the beginning. So you will have an increase of anything between 0.1 and 0.3 grams per liter during MLF. And obviously they have specific profiles from an aroma perspective that they will contribute. On the other side, the Plantarum prefers higher pH, but we've seen now that there is one or two strains on the market that can definitely function at the lower end of pH. They do not grow in wine, so they survive. So what you inoculate is the cell number that you will have in the wine. So they can mostly survive up to 14% ethanol, which obviously makes them, I think, less problematic than in warmer climates, because we have in South Africa, which is classified as a warm climate, having naturally 15.5–16% ethanol for us is not a surprise in a hot season. They grow best at 20 degrees. Their sulfur resistance is lower than uni. They are in a different group of the lactic acid bacteria, so they do not produce acetic acid from sugar metabolism. So you will not have an increase in your volatile acidity if you use this as a starter culture. And they enhance the aroma profile of wines in a different manner because their genomes are different, and therefore the enzymes that they possess and the functioning of the enzymes in wine is a bit different. So obviously these two, you have to know your matrix to make a decision, is it the one or the other? Because there are limitations to Plantarum, where uni is a broader spectrum MLF bacteria. Then the two inoculation times is you can either do your alcoholic, and then after alcoholic, which I think is still globally the most practiced MLF procedure. Obviously, here in warmer climate regions, the impact of high alcohol and the depletion of nutrients by the yeast still is problematic with regards to stuck alcoholic fermentation, which obviously in your scenario is not, I think, the biggest factor, where simultaneous and co-inoculation, obviously you inoculate in a sugar environment, so there's no impact of alcohol, there's enough nutrients available for both the yeast and the bacteria. And obviously MLF normally completes with alcoholic or shortly after. That means you can stabilize your wines quicker. So obviously the scenarios within the 2 inoculation times are important. So if I have to generalize what as winemakers you can do, so these are the typical descriptive terms that you will hear if you taste MLF versus not. So either you are driven for a nutty, yeasty, yogurt, buttery character, or you will be more on the fruit-driven side. So on top, on the right-hand side, you can see it's the same wine, the same bacteria. By just changing your inoculation time, you will change the overall profile, aroma profile of the wine. So sequential, definitely buttery was the character that the panel picked up as being the most prominent. And then all the fruit characters that was prominent in the co-inoculation wine, you can see is in the background. So the dimensions of the characters are different between sequential and co. And by just doing MLF in a tank versus a barrel, you will see this is a Chardonnay wine from a study in 2014. The dark line there is the one that was in tank, and you can see it's much, much more fruit driven, where the ones in the oak barrel, where you did the MLF in barrel, you have much more of your butter, vanilla, oak, and spice characters. So by just altering the vessel that you will use for your MLF, will in the end then also impact the aroma profile. So as a winemaker, as usual, you have a lot of choices. As with yeast, the amount of bacteria is luckily not around 300, but around 50. So you have to ensure you understand your matrix. Many winemakers in South Africa will analyze everything for the yeast. They will know the YAN and the sugar and the pH and everything else, and they will plan the alcoholic fermentation to perfection. Choose the yeast strain according to the matrix. None of this, or very limited, winemakers will analyze to understand what is the matrix the bacteria has to function in. So because there you have the option, either you choose a strain, for example, for alcohol tolerance because you have very high sugar levels, or you have to choose from a pH acid perspective, which in your case is obviously very relevant, or you have to choose from a sulfur perspective. Temperature, I think it's fair to say today is not the biggest factor, because most wineries and winemakers can control the temperature during MLF. So the important thing is, as with the yeast, you actually have to think about MLF before you actually start your winemaking process to ensure you choose the right yeast, you choose the right bacteria, and so forth. You cannot leave the poor bacteria in the lurch and think by just adding it will do its thing. It's like anything in life. The better the conditions, the better the bacteria will function. So you have to understand your matrix. And as we say in science, you cannot assume anything. You cannot assume because you added 30 parts per million of sulfur that is what it will be after alcoholic fermentation, because yeast can also produce sulfur. So this is, for example, I think in cool climate conditions, the impact of lactic acid on MLF is something that we understood very little about until about 5 years ago. So this is a Pinot Noir wine, which I think have typical characteristics as in your situation. So ethanol is around 12, pH of 3.2, malic acid of 3 grams, and the temperature of 16 grams. So we started realizing that lactic acid has an impact on the bacteria. So the end product of malolactic fermentation actually becomes a negative compound towards the bacteria. So the first bar here was the normal wine, and you can see without lactic acid, it took about 33 days to complete MLF, and you can see the cell numbers was around 10 to the 6. So what you inoculated was still there. If you have 1.5 grams per liter of lactic acid, you can see that you almost double, 2.5 times the amount of time that is needed for MLF to complete. And you can see there's been a reduction in the cell numbers to below 10 to the 6. That's our magical number that we want from the cells. And then if you have 3 grams per liter, which in your scenario, cool climate, you have, I assume, 6 to 10 grams per liter of malic acid, you easily can end up with lactic acid of 3 grams and more. And you can see there's a 2-log reduction in the cell numbers. So there's a high loss in viability. And this has led to stuck MLF. This is for Unococcus uni. At the moment, there are studies underway to look at the impact of lactic acid on Plantarum, because this season in Europe, we know that there was a high malic acid concentration and low pH, and it seemed like Plantarum fared better in these conditions, and we are currently evaluating to see if they are more resistant to lactic acid. So in your scenario, this will obviously impact the time that it will take for MLF or the percentage of completion that you will have. So nutrients are very important. This is a study with Chardonnay, with the compliments of my colleagues at Lallemand, where you can see the 2 green lines and the blue lines are the inoculated wines, and the top line is the spontaneous. And you can see the green lines received nutrients in the form of amino acids and vitamins. And we can see that we reduced the time that it took to complete malolactic fermentation by about 15 days. So, and what is important here, if you work with musts that are nutrient deficient, your YANs are low, it means the yeast will probably use up most of the nutrients. Bacteria, you must remember, cannot use ammonia, which is the major source added for the yeast. So they need amino acids as their primary nitrogen source. And Lactobacillus plantarum has a much lower need for amino acids compared to Unococcus uni. So that is something that you can evaluate. If you have a block of grapes that's always struggling, look at the nutrient status and maybe see if Plantarum is not a better option because of the amino acids that the must might be deficient for. So yeah, as I say, we've tried this year and in 2019 when the conditions was quite favorable for difficult Chardonnays. And again, you can see Plantarum was used in this case, pH quite low, average alcohol, sulfur not too problematic. So this green line is the Unococcus uni that was inoculated, and the red one is the Plantarum. So you can see this is about 2 months after the wine was made. So yeah, so obviously Plantarum, although in literature it's known not to function very well at pHs below 3.4, there are definitely now indications because Plantarum is double the amount of bacteria or cells per mil than Unococcus uni. That's how it made. So there's just more enzyme available to immediately convert the ml. So if you have a difficult wine and uni is maybe not doing or performing as you would like it, maybe do a small scale test by seeing if Plantarum is not a better suited bacteria for this. As I said, one of the factors that people are not thinking about in many cases is the impact of the yeast strain on MLF. And this is a Chardonnay. You can see malic acid of around 4 grams per liter, which I think is maybe typical of your area. We used 2 different Unococcus uni bacteria and 4 different yeast. And you can see there's only 1 yeast and bacteria number 2 that actually had the ability to complete MLF. So do not underestimate the impact of the yeast strain on MLF. So your yeast bacteria combination is really crucial to make life as easy as possible for the bacteria. All the companies now, I think, have classified the yeast MLF friendly, not so friendly, or they have a moderate or average tolerance. So they are normally divided into 3 groups. So you can see group 1 is there's normally a longer lag phase. So the bacteria struggles to adapt in many cases to the yeast, where the second group of yeast is more neutral. So they live together quite nicely, and the yeast and the bacteria goes about their business by doing it. So you can see a nice steady decline in malic acid, and then yeast 3 is more stimulatory, so they support MLF better, and you can see that there was a quick degradation of malic acid, and within 5 days the process was completed. So our question was, what is the impact of this from an aroma point of view? And you can see that this is a yeast from group 1. And this is the total ester level that was measured in a Merlot wine with co-inoculation, because we wanted to see the impact on fruitiness, the sensory profile. So group 1, this is the profile from a group in the yeast in group 1. And you can definitely see it has the lowest level of esters produced, because obviously the impact on the bacteria is bigger and there's less bacteria that's viable to produce aromas. So group 2, you can see has increased a bit, and this is the stimulatory or the MLF friendly yeast group here at the back. And you can see compared from year to year, you've almost doubled the potential contribution of the bacteria to fruitiness of the wine. So pH and ethanol is important, and I think these are things in the cool climate region. This was a study done in collaboration with Germany, where we used Riesling from cool climate and Chardonnay from South Africa, more warm climate. We tested 2 different bacteria. So I'm only going to show the one. So you can see low pH, low ethanol is not the biggest factor for malic acid degradation and the functioning of the bacteria, because we almost reached completeness for malic acid degradation. As soon as you enhance the ethanol concentration and you have low pH, you can see that you only had 24% in the Riesling that completed or degraded malic acid, and in the Chardonnay it was around 50%. And there's a direct correlation between the cell numbers. So obviously these conditions impacts the growth of the bacteria. So low pH, high ethanol, more permeable. So your potential of pH difference between the inside of the cell and the matrix, I think acidifies the cells, and therefore you get quicker die-off of the cells. So in your case, I'm not sure what your general alcohol concentration is, but if you start to move to 13.5% and above, the low pH and the alcohol becomes a problem. You can see high pH, high ethanol, you almost got complete MLF. So pH definitely interacts with ethanol in a manner that it really becomes very problematic for the bacteria to perform MLF. So, and we then also analyze the wines. So you can see at the low pH end here, the wines were much more driven by your acetate esters, more fruit-driven characteristics. And as we went along the scale to the high pH, it was more of your long-chain fatty acids and your acetate esters. So as a winemaker, you can adjust acidity in your wine by adding tartaric acid and so forth. And by doing this, you can actually, just by changing pH, you will shift the potential aroma profile of your wine. So you can manage your alcohol and pH as a winemaker and think about these 2 parameters from an aroma perspective. And then we were also involved in a study in Riesling wines, and you can see these are the starting pHs of the wine. So it was around 2.9 to 3.1. So we had co-inoculation, then during alcoholic fermentation and sequential, and we had a bacteria that was less ethanol tolerant and one that was more pH tolerant to see. So the bottom line is the grape matrix in these harsh conditions was definitely for the green strain, which had a bigger pH and ethanol span. Took 50 days in co-inoculation, and you can see almost 80 days for the sequential, where in the orange strain, the time that it took was not very different. So pH, obviously in South Africa, we have pHs of around 3.4 to 3.8, and our MLF normally finishes within a month. So obviously low pH extends the time. So you have to be patient with these little bacteria in the cool climate, very high malic acid concentrations. And we asked ourselves then the question, what is the impact on aroma? And you can see the blue is all the co-inoculation for all the different esters that plays roles from apple to fruity to floral, banana, that in co-inoculation compared to the red bars, which are sequential. in all the scenarios, there were higher levels of all the esters produced with co-inoculation, which obviously impacted the total ester concentration that is normally perceived as higher. And this is why the sensory profile is mostly described as fruit-driven. And in the same experiment, obviously, we looked at the bacteria. So all that you need to take from here is if you inoculate the bacteria in a grape matrix, their natural genetics and capabilities are more diverse and more pronounced. They express more because in a grape matrix, all the precursors, all the compounds are available to the bacteria. Whereas if you inoculate in sequential, you can see there's no major distinction between the two different bacteria because the yeast obviously uses a lot of the potential precursors for the bacteria. So your matrix becomes a bit more one-dimensional from a perspective where the matrix really defines the potential of the bacteria, whereas in the grape matrix, the bacteria actually drives the potential of the end product. So you can think about the bacteria differently when you inoculate in a grape or in wine. This was a study that used cool climate grapes. So you can see the one looked at the MLF procedure, and you can see this was done over quite a few vintages. I just selected it too because I assume Chardonnay, talking to Nestle and Francesco, Pinot Noir, I think, and Chardonnay are the two more important cultivars in your area. And you can see malic acid concentrations of between 6 and 8 grams per liter. And in the Chardonnay, it was only the co-inoculation that finished. In the Pinot Noir, the co-inoculation, and you can see, for example, in the 2012 season, even the co-inoculation didn't completely finish MLF. And this is directly, you can see, related to the amount of lactic acid that is produced that is above 3 grams per liter. So if you are working in a very harsh environment, very harsh conditions, maybe co-inoculation is a better option than sequential because you will bypass most of the negative impact of lactic acid under these conditions. So this research and group then also did chemical analysis. So co-inoculation produced more esters, where sequential produced more diacetyl. And this directly correlated with the sensory perception. So this AF is only alcoholic fermentation. So you can see there's almost none of this buttery, nutty character, but more fresh fruity. This is co-inoculation. So you can see you really push the fresh fruity floral with an undertone of buttery and nutty. And you can also see that in the sequential wines, the buttery, both in the white and the red, are more dominant with an undertone of fresh. So as a winemaker, you have to decide for your market or your consumers, what is the major style that you want? Is it more fruit driven or is it more buttery driven? Because then you have to think about your inoculation strategies differently, because buttery is driven only or mostly in sequential, because the metabolic pathway is inhibited by glucose, so sugar. So, and therefore the time that you normally have in co-inoculation is limited because the process is finished sooner than later, where sugar is normally then not an issue and you stabilize the wine very quickly. So if you have wines that are reliant or cultivars on monoterpenes and nor-isoprenoids, Plantarum's beta-glucosidase enzyme. This is the enzyme that splits the glucose that makes monoterpenes and norisoprenoids in grape must, non-aromatic. We've done several studies where we've evaluated different strains, and you can see that Plantarum, for example, here with geraniol, that's responsible for the rose character, produced almost 2.5 times more than, for example, Unococcus uni, which is the brown and the green bar, and the same for the violet or floral characteristics from the norisoprenoids, for example, beta-ionone. You can see the uni almost produced nothing, and the Plantarum produced 5 times more. So if you have cultivars that are reliant on these characteristics, Plantarum might be a better option to drive them to reach the full potential of the grape must. What about Non-Saccharomyces Cerevisiae? I'm not sure how widely spread the usage is of inoculating with non-sac. In some of the winemaking regions, it's becoming something that people are doing. And we need to understand, if you add Saccharomyces, you add non-Saccharomyces, and you add the bacteria, what is the impact of these 3 groups, especially in a co-inoculation scenario where they have to function together? So there's quite a bit of research activities in this, but the take-home message from this is that the wines are definitely impacted differently by the different non-Saccharomyces yeast. Some of them are more favorable for MLF than others. And in the end, the aroma profile of the wines are driven totally differently if you have different non-sac with MLF. So this is something you have to keep in mind and think about if this is something that you will do in your wine. So to end off, or to summarize, as a winemaker, I mean, it's fair to say that you hold the question mark in your hand. So you have to ask the questions. What does my matrix look like? What yeast will I use? Will I use bacteria for the speed of MLF? I just want to get my malic acid out of the way, degraded as quickly as possible. That's my main aim. I want to stabilize my wine. Do I want to use the diversity of bacteria? Do I want to use Plantarum? Do I want to use uni? And if you do spontaneous fermentation or MLF, I mean, how does your bacteria profile look in the wines? What will be driven? Is it more uni, more Plantarum? Or am I actually using MLF to drive my final wine aroma profile? Because I either want more fruit-driven wines, wines that can be released easy on the market, or after a very short time on the market. So then maybe co-inoculation is a better scenario for you. If you want a wine that can age for a while, if we think about Chardonnay, obviously you can do sequential. You want to complement the wood with a buttery to enhance the complexity and the structure of the wine. So as a winemaker, you've got the toolkit. You need the answers to make an informed decision to make sure your bacteria stands the best chance to be successful from an MLF point of view. So it's not you do everything and then you add the bacteria and it needs to just adhere to what it gets. Unfortunately, we've realized it doesn't work like that. There's too many factors that either the yeast can produce products that inhibit the bacteria and so forth. So you have to make sure that you make a decision, you understand your matrix, and you design your MLF strategy accordingly. So it puts a bit of pressure on you guys to ensure you make the right decisions. And to make the right decision, you need to measure your wine or your grape matrix to know exactly what are the conditions the bacteria will need to adhere to. So yeah, baie dankie, thank you Inkosi, and I hope there will be some discussion and questions. So that's all from my side from a presentation point of view, and I hope I kept to the time more or less.
Thank you very much for your presentation. It was very informative and we learned a lot about all the different tools that we have in our toolbox. It was great. Thank you very much. And now we will pass to the Q&A part. Francisco, can you lead us through that, please?
Absolutely. And first, Maret, I will read you some comments that they appear in the chat after you ask these couple of questions. So we have somebody said that the biggest issue is the low pH. Somebody else said that the issue is the quicker malolactic fermentations with no inoculation and very low pHs. So these are a couple of comments from the chat.
Okay, so yeah, obviously, I think the low pH in your area is probably the biggest factor. And as you saw from the presentation, there's new possibilities in your toolkit that you can definitely use that was not there 10, 15, 20 years ago. Strain selection, I think it's fair to say, has become really a science and an innovation and a technological advancement where strains are selected for very specific conditions. And I am sure in Canada, there are also research groups who are looking at your microbial flora that you have available naturally. And if any of that flora through evolution is better adapted to your specific conditions, because that's definitely globally a tendency where people with very harsh or very specific conditions are looking to use what is naturally evolved within that matrix, because they are normally better adapted than, say, some of the commercially available strains. But I think people have underestimated, sometimes you have a bacteria and you inoculate and you think they just have to do the job, which unfortunately it's horses for courses. So you have to know what are your conditions, and you have to select your bacteria carefully to ensure they have the resistance or will survive in those parameters to do MLF. So yeah, I mean, I don't think we can say that low pH is very difficult, because low pH affects the effectiveness of sulfur. So your sulfur management has to be very precise. We saw that ethanol can impact the impact of low pH. So low pH is something, if I think about cool and warm climate, I think in warm climate, it's fair to say we can probably get away with a bit more because the conditions is not as harsh as low pH. So low pH is the one thing in cool climate that needs to be managed and thought about very carefully in the way you will plan your MLF strategy.
Perfect. Thank you very much, Maret. Now I will pass to the questions. We have a couple of questions. So the first one is, what is the optimal YAN level for spontaneous malolactic fermentation?
That's, I think, a difficult one, because YAN is yeast assimilable nitrogen, which obviously the major part is ammonia. And as I say, ammonia is not used by bacteria. So YAN is more an indirect indicator how easy the matrix will be for the yeast. And if the yeast is struggling because of a low YAN, then we assume that the yeast will use most of the nitrogen sources available in the must. So if you do malolactic fermentation after sequential, it is a better strategy to add additional MLF nutrients, which is made up of mostly peptides and amino acids, which are used by the bacteria, and obviously some of the crucial vitamins and microelements. So YAN is used as a yeast indicator, but if the YAN is very low, it might be an indirect indicator that we need to think about nutrient management for MLF as well.
Okay, so this question is quite linked or similar to the previous one. Is, do you recommend nutrient addition in co-inoculations other than yeast nutrients?
No, I mean, I wouldn't say you cannot, but in our experience, the grape must actually has enough available for both the yeast and the bacteria. The yeast is very effective. So if there's no challenge, what is available, they will consume. But if there's something else that needs it, it will be available for the other bacteria. So grape must, from a bacteria deficiency point of view in co-inoculation, I think is fair to say that the matrix normally has enough for both the yeast and the bacteria. But obviously there are exceptions where if you have a very bad season, I assume with a lot of rot, where the grape health is not very good, that will impact your amino acid profile, because obviously there's fungi and other spoilage bacteria that will grow. But in principle, in most of the studies we've been involved in, and also in industry, it's not normally necessary to add additional nutrients if you co-inoculate.
Perfect. So now it's for co-inoculation. Does cold maceration at the beginning of fermentation or cold fermentations matter for the addition of malolactic bacteria?
That's also one that obviously depends on the period, because some of the phenolic compounds can impact the bacteria. So if you do it too long, you might see a longer lag phase if you inoculate in co-inoculation. And sometimes obviously your competition will also be higher, because the grape skins that carries the natural microbes will add natural microbes on top of what you will inoculate. So, but I think in low pH conditions, it shouldn't be the biggest problem, because you will add sulfur then after cold maceration. And I think most of the natural flora will be inhibited because they're not selected for high sulfur tolerance. But yeah, it is something that you have to think about and can impact. On the other side, it can also be positive, because you might extract more precursors from a aroma potential point of view, and obviously also some nutrients from the skins. But depending on the grape quality, that is the decision that will drive, should you do cold maceration or not? And that's both for the yeast and the bacteria, actually, and not just the bacteria.
Thank you very much. I have another question about yeast strains. Now it's, would you recommend yeast strains that reduce malic acid during fermentation?
Oh, in cool climates, my gut feeling tells me no, because you will just add more malic acid on your very high malic acid.
No. This is strains that reduce malic acid. So they will
reduce malic acid.
Yes.
No, if you think about the Chardonnay example that we had, the yeast and the bacteria combination that was successful in that matrix, that yeast actually assisted with also having the ability to reduce malic acid. So it definitely assists the bacteria in making sure that the malic acid is as completely degraded as possible. So yes, it's something that can be evaluated if you find that the bacteria does not have the ability on its own to degrade the amount of malic acid in cool climate conditions. So in that Chardonnay, the yeast 4 that was successful with bacteria 2 has the ability to degrade malic acid, for example.
Perfect. Thank you. We have 2 more questions, Maret. The first one is, what's the recommended timeline for testing malic acid levels? Should it be at one-off test, or should it be monitored over the course of the malolactic fermentation?
I mean, to make a decision, I mean, for us in warm climate conditions, we sometimes end up with too low malic acid concentration. So obviously for us, we will measure malic acid as a standard parameter before we inoculate, because we sometimes have to add malic acid to ensure there's enough for the bacteria, because there's a threshold limit for the enzyme and the genetics to be activated is around 1.5 grams per liter, which I assume in your conditions is never an issue. But in warm climate, we sometimes get, especially the late ripening cultivars that come in with 1 or 0.8, and then we have to add. Otherwise, the bacteria will not be able to degrade. Even if it's low, the enzyme is not produced. So I would say in your conditions, obviously knowing how high it is and what the potential is of the lactic acid, I would measure before inoculation, and then obviously maybe a month, because I assume I don't have context of obviously very cool climate conditions, but I can imagine that your MLF takes 2 to 3 months to be completed because of the cold temperature, the high malic acid concentrations. Then obviously I assume measuring, say, once a month until it's complete should be enough.
Perfect.
But you can correct me if I'm wrong with my assumption, but I would assume in cool climate that the time frame is 2 to 3 months to degrade that amount of malic acid.
Yeah, it could be even longer depending on the place, but it's fine. So I will ask this last question from the Q&A, and I will ask you something too related to the same thing. This is more like a analytic chemistry. It's recommended method of testing, such as is FOS analysis sufficient, or should it be the HPLC analysis, which has a much lower limit of detection, the best way?
In our experience, in our own environment, the FOS is definitely not to the lower end of malic acid very accurate. So in our experience, anything below 1 gram per liter, we either go to an enzyme, we have an automated enzymatic robot where we will use a kit, or HPLC, because there the FOS is definitely not the most accurate. I know there's new calibrations with the handheld UnoFOS and the smaller devices. I'm not so sure how accurate that is, but in our experience, we don't trust the FOS below 0.8 grams per liter of malic acid. Then we convert to another way of measuring. So I would say the HPLC in the lower end is definitely more accurate from an analytical point of view.
Perfect, thank you. And Maret, just to wrap up, and this is my question because we are in a cold climate. So about temperatures, which should be the range of temperatures where the bacteria works in a better way?
Optimally, MLF takes place between 18 and 22 degrees Celsius. And the reason is not because that's the most optimal temperature for the bacteria, because we all know that's around 30 degrees, but because of ethanol in the matrix, which reduces the optimal temperatures. So yeah, but uni definitely will survive between 12 and 16 degrees and slowly convert. Plantarum, I think, struggles a bit more at very low temperatures, 12, but as temperature will be low, there will be ethanol. You have low pH. The lower your temperature, the longer your time. So it's not to say temperature will impact that to the negative where it will not happen, but it will extend the time because the bacteria from a metabolic point of view have to work much harder at very low temperatures. So, but I assume 14 to 16 degrees is sort of naturally what's your MLF temperatures. It's just compared to what we do with 18 to 20 degrees, you will add a few weeks onto the process.
Perfect. Thank you very much, Maret. We passed through all the questions from many diverse ways. And just to thank again, Nestle.
Okay.
Thank you very much, Maret, for everything. And thank you for all the attendees for their questions. And thank you for answering all of them, Maret.
No, that's a pleasure. And thank you for the invitation and introducing me to your organization, and also to Perennia, which I didn't know about. So hopefully this is not the last time we will have a potential interaction or a discussion. So if there are any questions, I assume you would like, or you've recorded. My email is on the first title slide. So anybody that has a question or would like to email me or have ideas or whatever, you are more than welcome to make contact afterwards. So, but yeah, as I say, hopefully Perennia and Stellenbosch University or our industry can maybe have a collaborative effort on webinars going forward. It would be nice. I really enjoyed it.
That would be great. We really made a lot of use already from your expertise, and we are looking for future collaborations. Thank you very much.
Thank you, everybody who's behind the screen. This is the bad part, not seeing what my audience looks like and interacting with you normally afterwards. If it's not online, is where the nice and informative questions discussion happen. But yeah, I wish you all a nice rest of your day, because for me it's evening. I'm going home now to have a glass of wine. But yeah, so thanks a lot. And if there's anything, please do not hesitate to contact me.
Thank you very much. Cheers.
Thank you. Bye-bye.
Bye. Finally, I would like to invite all the attendees for the next session. This will be our last session of From Grapes to Wine Cool Climate webinars. And we will be talking about flash detant technology. And that will be on Thursday at 12 p.m. AST. So we are looking forward to see you there. Thank you.